So these are the points usually we take. We're going to plug it in over here for x cubed. And every time you're plugging it in, I just broke down the negative 1 over here. If you have a negative 1 cubed, you break it down into negative 1 times negative 1 times negative 1. So minus and minus is going to make it a plus, plus and minus is going to make it a minus. So it's going to return you back a negative 1. For when you draw all the points, you connect. The domain is the x values, right? So you have to check if you can take any what x values you can plug in, so you can get a regular y value, and that's from negative infinity up to a positive infinity. What is the range? Negative infinity up to a positive infinity. If you look at this one, it's going to go anywhere and then go up anywhere. Increasing, is it increasing anywhere? Where? The whole time it's increasing. Any time you are making the x values bigger, y value is becoming bigger with it. So you're coming from negative up to, remember, you are dealing in the negative side. So the bigger the number is, the smaller it is. So actually what seems small to you, negative 1 is bigger than negative 2. So every time you are getting a bigger number, it's coming closer to 0. It means it's giving you a bigger number. So it's increasing every time. Decreasing, is it decreasing anywhere? Since it's increasing from negative infinity up to an infinity, it cannot decrease. X-intercept, do we have it? What is the x-intercept?
0.
What is the y-intercept?
0.
Vertex. Vertex is where you are changing the direction or the point of inflection. That's going to be also 0, 0. It's also called the point of inflection. I'm giving the word for you, so when you take the test, if you see this sentence, you don't get confused that what is the point of inflection that we're talking about. Symmetric. Is the graph symmetric anywhere?
Yes.
Where? Where? Say it again? Yeah, to the origin or to 0, 0. So it's symmetric across the origin. Roots. Do we have any roots? X equals to 0. Whenever it's a root, it's the x value. So it's x equal to 0. Asymptote. Do we have any? What is an asymptote, by the way? A line, and the graph will never touch that line, cross that line. Okay? So that's the asymptote. Do we have any? No. Maximum. Do we have any maximum value? It's going to keep going forever towards the infinity, positive infinity. So we don't have any. Minimum. Do we have any minimum? None. Axis of symmetry. 0, 0 is a point. That's not an axis of symmetry. It needs to be a line. Either x-axis, y-axis, any line. Is there a line? No, there is none. All right. That's for the cube function. We're going to talk about the cube root simultaneously, so you can see the difference between it. So we're not working on this one right now. We will come back to this. Go to the cube root. Pay attention to the values over here. Look at these values on this side. So all the x values, look at the x values that you use. All the y values for x cubed became the x values for the cube root. So it's just the mirror image of each other. They're the inverse of each other. Okay? So whenever you are flipping the x and the y values, they actually are the inverse of each other. So whatever y value you had, that's your x value. So whatever x value you had for this one, you're going to have that for the y value. You can even check that whether they work or not. If you plug in 0 in the cube root, it's going to return you back a 0. if you plug in 1 over here, cube root of 1 is going to be 1. Cube root of 8 is going to be 2. And then negative cube root of 1 is going to be negative 1. Negative cube root of 8 is going to be negative 2. We are going to plug in. Let's plug in all the values. 0, 0. Then we have 1, 1. Then we have 8, 2. And then on the other side, negative 1, negative 1, negative 8, and negative 2. All right, let's connect. We flipped it. It was vertical, now it's horizontal. Let's look at the properties. What is the domain? What's the domain? X values. Negative infinity up to an infinity. I can take any value. It's going to still give me y values. What is the range? Range. All the y values. Increasing. Is it increasing anywhere? Definitely. Where? 0, 0. It's increasing to 0, 0. The whole time it's increasing. Every time. Because any time you are putting a bigger x value, your y value is also becoming bigger. Decreasing. Is it decreasing anywhere? No. All right. X and y intercept. X intercept. If we have a 0, 0 x intercept, definitely the y intercept is going to be also 0, 0. Now the vertex. What is the vertex? Vertex is also 0, 0. Or we can say the point of inflection. I'm just giving this term every time so it's stuck in your head whenever you take the test. Symmetric. Is it symmetric anywhere? Is it symmetric anywhere? Where? To the origin. Roots. Do we have any roots? X equal to 0. Asymptote? Any asymptotes? No. Maxima? Minima? Axis of symmetry? No. All right. Now we're going to talk about the transformation. Now let's go back. Over here the transformation rules are same. I just didn't attach the paper one more time because you have the same paper over and over. So in this packet I didn't add that anymore. But you can look at your previous packet. In Unit 6 you will have the same transformation rule. Over here we are talking about the cube. So again, if you go to the left and right, it's going to be inside the function. If you go up or down, it's going to be outside of your function. And if you have a multiplier over here, it's going to be, if you have a multiplier here, vertical stretch, if it is a whole number. And if it is fraction, it's going to be compression. If I have a negative over here, it's going to be x-axis. If I have a negative over here, it's going to be across the y-axis. Thank you. All right. Now let's look at this one first. Let g of x be a horizontal shift of 3 units to the left of f of x is this one. So the new function is g of x. So g of x is going to do horizontal shift of 3 units to the left. If it is going to the left, is it plus or minus? Plus. So if it is plus, is it inside or outside? Inside. So how can I write it? Somebody give me. X plus 3. Don't forget, it's a cube function. Any questions? If not, then go ahead, do the next 3 boxes. I'm giving you 2 minutes. Okay, let's check it together. Give me this one. So how many transformation do we have over here? Two transformation. What are those?
Stretch 3, letter 4.
Stretch 3 and left 4. I'm not writing it. And how about this one? How can I write this one?
Negative x minus 3q.
Alright. How many transformation do I have over here?
3.
3 transformation. What are they? Reflection, then vertical stretch by 2 and
1.
alright. Going to the right 1 unit. Over here, these are also the transformations. You have to write it as a function of cube, as a cube function. So the new function is going to be g of x is equal to x minus 4 whole cube. And you have to write in words what are the transformation. What is the transformation over here?
Right 4.
Right 4. So it's the same thing for these two also. Go ahead, do the rest of it, like these 2 problems, and at the bottom there are 4 problems. Don't forget you are working on the cubic function. So make sure you are working on that one. I'm giving you 3 minutes. There are 4, 5, 6 questions. Go ahead, get started. Alright, let's check the answers together. I'm not writing them down. Please check your answers. This is the key. You good? Give me a thumbs up once you are done checking. You good? Alright. We're going to talk about the cube root now. The same transformation. I'm just showing you one. The rest of it you're going to do with. So on this one, we're talking about the cube root function. It's a horizontal shift of 3 units to the left again. Since it's going 3 units to the left, is it a plus or a minus? It's a plus. And inside the function or outside the function? Inside the function. So if we write this, it's going to be g of x equals to, don't forget it's a cube root, so there will be a small cube with your root function. Okay? And then it's going to be x, since it's going to the left, it's going to be plus. Any questions? We good? Great. Do the rest of it and bring it to me so I can stamp it for you. After you are done with this one, you are going to start working on the practice. Let me give you that one also. So if you go to your practice paper, you are going to work on the first 2 pages. So this is cube and cube root basics. There are 9 problems, there are 10 problems, number 1 through 10. And you're going to bring it over here. I'm going to stamp both of them during class. It's a very small topic, so we're going to finish it today. Any questions? All right.